Hey, folks. I wanted to take a couple minutes and go over with you the computer science principles create task and specifically question 2C, which is on algorithm design. This question is uh, broken down into three different rows on the test itself, meaning that you can get three different points just for this one question. So it's worth a lot. So it's worth taking a look at to make sure that you understand exactly what you need to do to get full credit for it. We take a look at the question first. So this is applying algorithms. And the first thing they're going to have you do is copy and paste your code and put an outline around it as part of your submission. And then in question 2C, what you're going to do is you're going to talk about that algorithm and how it functions inside your program. So reading this, it says you need to pick something that's going to be fundamental to your program to achieve its intended purpose. So meaning that you can't just choose an algorithm or a function that doesn't really have any purpose or real central need to your program. You can't just toss a function at the end of the program to have it meet these requirements and think you're going to get full credit. It doesn't work like that. So you're going to need to design your program knowing that you have to fulfill these requirements. That being said, these are very simple requirements to fulfill. So, I've had students in the past who have gone back and have rewritten their code in order to make it meet these requirements. And if your program is detailed enough, you can very easily do that. Uh, these are not very complex requirements. They're just detailed requirements that you need to meet. So your code that you need to select must include an algorithm that integrates other algorithms and integrates mathematical and or logical concepts. We'll go over each of those in just a minute. Describe how each algorithm within your selected algorithm functions independently, as well as in combination with others to form a new algorithm that helps to achieve the intended purpose of this program. As part of your coach on this one, I'm going to highly suggest you don't necessarily worry about the word algorithm because that sometimes can be confusing for folks. And just think of this as you're just designing functions. You're just writing functions. That's it. So what it's saying is that you have to write a function that has math or logical concepts, if else statements, in other words, inside of it. And then when it's talking about your selected algorithm functions independently, basically you have to have something like three different functions and how do they operate independently and how do they operate together. So we can go over that question in more detail here. So parts of the question, math and logic. You need to have math or logic inside of your program. Okay. You could create the most awesome Discord bot ever, but if it's not doing some sort of mathematical computations or if-else comparisons, it will not meet the requirements of this test. So just keep that in mind. You can design something awesome, but it's probably better just to design something small first where it will meet these requirements. So math and logic. You have to be able to explain how the selected algorithms function inside your program, right? What are they doing? Okay, you have to say it out in words, even though the code might be there. Where it fits. So you're going to have multiple functions and a parent one and two children one. And so where is that parent function fitting inside of the entire program? You can't just wrap the entire program in red and say that's your algorithm. That doesn't work. You have to choose something specific inside of your program, a specific function that fulfills these requirements, which means that your program has to be larger than just the function that you're writing to fulfill these requirements, right? Otherwise, you'd be wrapping your entire program in a function called like function main and saying that fulfills the requirements. It does not. Okay. You need to have multiple instructions. You need to have one parent algorithm, one parent function, and two child functions underneath it. And each of those need to function independently. So your functions need to function independently, meaning that they should perform their own calculations, they should deal with their own variables, and they should stand on their own, meaning that it's probably best to design them with parameters. In that case, you can easily make a function that takes in an input, does something to it, and returns a value back or changes a global variable or something like that. That's how to make sure that they operate independently. So let's take a look at some examples and see whether it counts or not. So all this is going to be written with P5.js, but it's all vanilla JavaScript underneath the hood. And so any editor that you're going to use that has an event listener that listens for a mouse press, mouse click, mouse move, something like that. That's what we're looking at here. So in this case, somebody wrote a program that, or an algorithm they submitted, and it says button 1, mouse pressed. We have a callback function here, that an unnamed anonymous function that simply sets the button 1 style to red, and if somebody clicks on button 2, it sets that to blue. So it's just modifying the properties or attributes of those buttons. Does that count as an algorithm? No, it does not. Okay, this does not count because this is just changing properties. And well, there's a couple things wrong here. First off, they're using built-in functions. They're using mouse pressed, which is built into the JavaScript library P5JS. You cannot use the browser's native functions built in to count. So event listeners are a trap. Do not use event listeners on event mouse clicked, mouse press, button change, anything like that. You cannot use those as your algorithm. Okay, if you try, you're not going to get credit because those are built in. You didn't write them, you didn't design them, and they don't count. Okay, how about this one? So we have a button 1, mouse pressed, callback function. We have 3 variables, random, that's just going to generate an RGB every time the mouse button's pressed. And then we have a combination of those RGB to a single string. And then let's see, button 1 style, background color sets background color, and color is going to be that random RGB. Now, ignore the obvious errors here, right? That this actually wouldn't work and probably throw an error. But this was an algorithm that was designed, and does this count? So we see math here, right? And that RGB to string, R plus G plus B. I think what they were trying to do here was actually combine RGB into a, like the color code RGB, and then pass it off to set the style to be that. But actually what it wound up being is just random numbers just being tossed together. So you get a really long number rather than actually the commas in between. They forgot the commas. Okay, so besides that, besides the program not actually working, does it work as an algorithm? And it's using math, right? It has the pluses there. And no. What that is right there is actually a string concatenation between the different parts, and isn't performing like a mathematical computation. It's not performing arithmetic. It's just combining those statements into one. Okay. So beyond that one attempt there to try to combine that string into one, this is just once again setting background colors. It's just changing the properties, the attributes. It's not actually performing any sort of calculation or if else statements there. Even the random generation of numbers there. Yes, it's like randomly picking numbers, and isn't that math? That doesn't count, right? Because you're using the P5JS random function to generate those numbers for you. It's not like you designed the math that goes behind the function to generate those numbers, right? You're using somebody else's function. Doesn't count. Okay. So this one's a no. All right. So algorithm number 3. So here we have function manage login. Okay. We have if login status equals logged in. We have a go to home function as a result, else refresh login. All right. So basically, do you log them in or not? And we see the go to home function as a window location. So it's just setting the screen to a new website, new web page, home. And we have refresh login. We set the login status to be as logged out, and we set the page to be login again. So I would assume that when this code is running on the login page, okay. So does this count? This one does not count, and it's pretty close, but probably no. And where it's gonna not make it is, yeah, I understand that there's a main function, manage login, that has an if else statement inside of it. But the two sub algorithms, the two sub functions, the two child functions there, go to home and refresh login, they do not. They have no math, they have no logic, and yeah, depending on the readers, you may, it's borderline, but I'm going to say borderline probably not. So, if, in coaching you, I would say that I would develop something that's a little bit more complex than this, that there's maybe this manage login has some other checks that go along with it, or go to home has some, it does something else. Maybe it modifies variables or something else, or refresh login does, so there's different things you could add. Doesn't I would generally recommend that each function you add, this is only one part of your main program, right? So, but you have to include a function that has two child functions. I am recommending to you that you have math and logic in all of them. So your main program has some sort of logic in it, or math, your main algorithm. And then the two children one, in here they actually broke it up into two separate locations. The two children ones that go into the main one at the top, that those include math and or logic as well too. I think it's just the safe way to go here. And let's take a look at another one here. So this is algorithm example number 4. We have 3 different functions here, one parent, 2 children. So increase score, we have a score increase. It increases the variable by 1. We have a check win, runs the check win function. If game over is true, result text.html sets the result text paragraph HTML to U1 in the number of seconds. And else go to results. So we have a simple if-else statement similar to before, but we have math here too as well. We have score plus equals 1. So this is actually hitting on both math and or logic. It says you don't have to have both. This one has both. That's great. Then function go to results, and we set the position of the text, and we have a string concatenation with result text.html score plus. So basically, it's just saying, it's kind of a weird wording here, but it basically has the score variable and then score. I think they might have put a semicolon there. It would work fine. It would just be score plus score. I don't know. Function check win. Okay, what this person does is it goes and uses the JavaScript get time function, and so it sets the end time basically now, and it calculates total time. So this counts, right? So this person sets up a simple equation here to basically find out how much time has elapsed. They set game over to be false, a game over variable to be false, and if the score is greater than 10 or the total time is greater than 20, set game over to be true. Okay. And that check win happens above, right below score plus equal 1 in the function increase score. So we see logic there, right? Yeah, go to results doesn't have logic, but the program is asking for multiple math and logical concepts inside there. So, the readers are looking at your entire algorithm holistically, and they're trying to give you as much points as they can, right? So, yeah, if one of your functions maybe doesn't include math and logic inside of it, but your other two do, and there's multiple levels of it, can they give you credit for it? Absolutely. Okay. What I would have suggested to this person is that in their function go to results, that they include math or logic there. Maybe something beyond a string concatenation. You can't just add strings together like I think they were trying to. You have to include some sort of math or logic here, but that's what I would recommend, is that you include it in all of your functions for them to count. Now, I've been talking and coaching you the entire time that, when you design your functions, that you need to have them to be, you need to have them clearly labeled there. And this is what I'd recommend, that you have each of the functions separated out into their own function name. Each function gets a name. Each one has its own math and logic inside of it. And then you have a parent function, such as the increased score here, that you're calling on these functions inside of. This is like the fail-proof way to get credit. Okay. Can you nest the functions? Meaning that can you have increased score that has a check win, and inside that check win, maybe there's another helper function that helps out the function above it. So can you nest them down rather than just having a one function that has two child functions? Yes, you can technically do that. Can you have a multiple helper functions and then just change where you call on them? Yes. I would recommend, though, that you double check to make sure that those functions, each of them, can operate independently, meaning that they have their own variables, they have their own parameters that they're accepting, that they return their own values, that, you can call check win on its own. And in this example, we can call check win on its own or call go to results on its own, and either one is going to work. on their own. They are independent from one another. And you may run into a problem with that if they're nested, right? If they're stacked on top of one another and we have one function calling on another function, which is then calling another function. At the same time, an example of a helper function that you nested on the third level down, that might work. I don't have an example here ready, but something off the top of my head would be if you had a helper function that did some sort of math calculation, function multiply, and it performed a simple multiplication and it returned that value back. You could call it on its own, right? Because maybe it's accepted a parameter of, x and y, and it multiplies x and y. That would work, right? Because that's an independent function on its own that you're just calling on the third level down. That's okay. I think that would be just fine. But just make sure that, you're not nesting them down and that, they can't be accessed, independently inside the program. That's why putting them all on the main level, right? You're putting them all in the main program here. Function increase score, go to results, check win. They're not defined inside one another. They're defined globally. That ensures that they can be called independently, right? Because if you nest a function inside of one another, it can only be called inside of the function that it's defined in. Okay. So calling it inside of nested functions is fine. I would say defining it globally is a better way to go. So this one counts. Okay, this one would have gotten, basically, depending on their explanation, right, because those are additional points, writing the code, this would have been just fine. And you see here, there's nothing really here that is complex, right? In fact, these folks, they didn't even use return values. They didn't use parameters. That might be a problem later on for one of the other questions. But for the simply algorithm design, there's really not much here that's really that complex, right? There's no arrays, no objects, nothing really complex here that maybe if you're more comfortable with coding, you'll be able to write. This is fairly fundamental stuff that you're trying to do here. Okay, interacting with the DOM, the document object model, right? The actual website itself, modifying some of that HTML, and then going and performing a little bit of math on it. This is really not all that hard. Okay, you just have to make sure that it meets the requirements of the exam. Okay, here's one. Let done equals false, or get false. While done is equal to false, we prompt the user, enter your secret number. If the user number equals 97, we set done to be true. And we set result HTML, you did it, begin countdown. Okay, so if they guess right, I guess. And then it does a countdown starting from 97 all the way to the bottom, and sets the result text once that countdown's over. Sets the result text, sets the HTML to be access granted. Once again, we're just setting the text. You guessed correctly, and if user num is less than 97, guess higher, else gets lower. Okay. So, does this count? Well, let's take a look. There are no functions here, right? Breaking it up into functions is something that I would highly recommend that you do. And I think it is the easiest for you to organize your code, easiest for the readers to see and understand. Okay, this code is a little confusing when you're reading through it. Like they're sending a lot of HTML and doesn't make sense where they're putting it. Okay, we have nested if statements here. I suggest we think of algorithms as functions. Okay, just because it's easy. But algorithms are not explicitly functions. Algorithms are the logical steps of a program that it needs to take in order to accomplish its task. An algorithm is just the design of the program. And the design of the program does not explicitly need to break the program up into functions. Good coding and good programming practice suggests that's how we should organize the code, but it doesn't necessarily need to be that way. And you can have an algorithm that simply goes over your program, basically from the top to the bottom, right? Reading the code sequentially, and it will count as an algorithm. And here we look into see, does it have math or does it have logic? Does it have multiple checks for logic? And actually, we have 3 different points here that it does check for logic. First one we see is the while done equals false. That is a logic condition check, right? It's checking for the variable done and seeing if that is false. If it's false, it will not run this program. So initially, this is going to kick off to well done equals false. Okay, so this is going to kick off and this program is going to run. It's going to prompt the user. All right, and then in a loop, right? Prompt the user, enter your secret number. If that number equals 97, okay, I assume they're waiting for that number, right? But it does another logic check. If user number equals 97, set done to be true. It has code that results from that. We see a for loop. A for loop does not count as an algorithm, right? I mean, it does not count on its own, right? Only math or logic does. So even though it's counting, yeah, and it iterates by -1 every time, would that count? Probably not. You could try to sell it that it does in the explanation, but as coaching you, I would suggest that you probably don't do that. Rely on that. Then we see an else, and we see a nested if statement. Okay, so we see if user num is less than 97, set result text, set result text. So the expression, right? The code that runs as a result of the if user num is less than 97. That result text HTML gets higher and gets lower. Okay. Technically, I mean, there's not like math logic inside of there, but the logic is the if else statement there. And that counts. So we see three conditions. While done is false, if num equals 97, user num equals 97, and if user num is less than 97. Those three occasions there, if explained properly inside the response, does mean this counts as a full credit algorithm under the guidelines. Okay. Now it's up to the programmer to the student programmer to go and then explain that in their response. But if they can meet the explanation and explain how it works inside of the larger program and explain how each one operates independently, okay, then they would get full credit for this. Okay. But it just shows that going back a couple of slides, right, we could take a look here that this person broke their algorithm up into functions. This is the way I would recommend it. It's the way I think is the best way to accomplish this task. Okay. And this person does not break it up into functions, yet it still counts. Okay. So there's options for you here. But either way, I wanted to show you that this is not a hard task. You just have to make sure that you check off the boxes to make sure that you're meeting all the requirements of this exam. Okay. If you can do that, then this is it. Yes, you should put this into a larger program, but it doesn't need to be that much larger in order for you to get credit. Okay. You don't have to build Facebook or YouTube or, Spotify in order to get full credit for this exam. Okay. You just have to make sure that you include multiple if else and or mathematical operations, right? Arithmetic operations inside of your program. Okay. And then you explain it and you're good. Okay. So I wanted to go over this with you so that you're feeling comfortable. If you have questions, feel free to ask them. I'd be happy to get back to you and answer anything that maybe I left out of this video. Okay. But you should be all set now to start writing your response. Okay. And if you don't design your program from the start to meet these requirements, it's certainly possible to go back before you submit and to make sure that you are meeting the requirements by restructuring, refactoring your code into the form that they need. I'd highly recommend taking a look at the resources that are available to you, which are going to be the scoring guidelines. It's basically a step-by-step procedure for the scorer to tell them exactly how they should grade this. And also any templates that you have, right, that tell you exactly how you should answer this question, and or the College Board Create Explore Task guidelines that are there available that provide the walkthrough for you and to answering each of the questions exactly what you need to do. Okay, you do that and you'll be just fine on this. All right, thanks for watching and good luck in designing your algorithm.